In today's lesson, we're going to be working with exponents. What we want to focus on in today's lesson is applying our exponent rules to various situations where we are given an expression, and you can see three of them here. We want to be able to break this down and express it in the most simplified form using our exponent rules. So let's go ahead and get started with these. So focusing our attention on the first question here, we want to simplify the following expression. And again, the idea here is when you're dividing with like bases, you subtract the exponents. So you'll see here right away I've got a common base of x right here. You're going to go ahead and subtract the exponent. So here this will simplify to become x, and the exponent here is going to be the 3 minus negative 1, which gives us a 4. Moving on here, we now have a base of y, and we're dividing with the same base. Therefore we can subtract the exponents, the 3 and the 2, leaving us with a y to the power 1, which typically people do not write the exponent of a 1, and they'll just write it as x to the 4th times y. In the next example, let's take a look again. I want to apply my exponent rules, but before I can apply my exponent rules, I have to expand this out. Right? I can't go ahead and start dividing the variables until I've got this all expanded out. So expanding out the bottom here, in the top we have our 16y squared. In the bottom, if you square the bottom here, we actually get 16y squared again. And this whole thing just simplifies to become a 1. And again, when you apply an exponent, in this case 2, to a product of expressions, it's going to go to every single one of these. So negative 4 quantity squared gives us 16, and then we have your y squared. Continuing on here in the next example, anything that's common, the numbers are common, we can try to divide them out and see if they simplify. Then we can move on to our variable x, our variable y, and our variable z's. So taking a look here, let's see what we got. 12 over 21 can be reduced by dividing top and bottom by 3, giving us 4 over 7. Now you'll notice the next one here, we're taking our x to the power of 2 divided by x. That isn't written. If it's not written, the exponent is a 1. So this becomes x to the power 2 divided by x to the power 1. Again, subtracting those exponents, you get just an x, or x to the power of 1. Likewise, we have a y here left over for the next one. And then for the z, you got to watch your exponents. This is going to be negative 2 minus 3 is going to simplify to become z to the power of negative 5. Now, it depends how you want to rewrite this. If you want to rewrite this more in the sort of way that they were doing it here, I can write this as 4xyz to the negative 5, the whole thing divided by 7. And we have our reduced answer. Let's take a look at some more examples. The rule we're seeing here for this first expression is a lot of negative exponents. If you recall here, x to the negative n is equal to 1 over x to the n. That was our negative exponent rule. So I can do that for all of these here, get rid of these negative exponents, change them to positive. It just costs me a flip. So in this case here, I can write this as 1 over 4 squared plus 1 over 2 to the 4th. Again, I'm just flipping, taking this expression, bringing it to the denominator, taking the exponent with it, but losing that minus sign. So you can lose the minus sign, you just have to push that number to the bottom, divided by 1 over 8. And again, you can put that to the power of 1 if you wish. All right, now we can go ahead and evaluate each of these terms here. So 1 over 4 squared, that's going to be 1 over 16. And then 1 over 2 to the 4th, that's going to also be 1 over 16. And divide that whole thing by 1 over 8. So this becomes 2 over 16 divided by 1 over 8. And you'll notice here I'm dividing a fraction by a fraction. If you remember, that's equivalent to multiplying by the flip. Quickly, we can reduce this. You see this will reduce to become 1 over 2. So this expression now becomes 2 over 2 times 1 over 1. And our final answer for this question comes out to be a 1. Let's take a look at the next one. So for this one here, again, we want to apply our exponent rules. You'll notice here, negative 3 quantity squared. So the whole thing is being squared. That's going to be a 9. Watch out, that's different than negative 3 squared. Negative 3 squared is equal to negative 9, whereas negative 3 quantity squared is equal to positive 9. And the reason for that is the exponent, in this case the 2, is applying the base of a 3, where this 2 is applying a base of a negative 3. So this represents negative 3 times negative 3, which is obviously positive 9. This represents negative 1 in the front, and then 3 times 3. So you get a negative 9 in this situation. Now if I go to the next expression, I have negative 2 quantity to the power of 4. That's going to be plus 16. And in the bottom we'll have a 1. So this whole thing comes out to be 25. Let's take a look at another example. All right, for the next example here, we have a rather lengthy expression to simplify. When simplifying an expression with a bunch of operations, you want to go through your bedmass rules. So brackets first here, we have two separate set of brackets. So in this case here, we can kind of tackle each of these problems separately, get our result, and then subtract the results of each one. So let's go ahead and start to work with these brackets. We can work with them simultaneously, just kind of cleaning up in steps all the way across. So let's go ahead and do that. So in this case here, go to my first bracket here. I want to simplify some of this. So 2 squared, I can rewrite that as 4 over 8. The 2 over 2, I can write as 1. And the 2 to the power of 3, I can write that as at 8 over 12. Put my minus sign back down. Now going into this bracket, see if there's anything that we can clean up here. Negative 1 quantity squared is going to be positive 1. And we have our minus sign from before. Put your minus sign down here. Now watch out. This is going to be negative 1 to the power of 3, which is negative 1. So this is staying this minus 1 symbol. I would go ahead and start reducing here. So 4 over 8 I can write as a half plus 1. And the minus 8 over 12 I can divide top and bottom by 4. Give me minus 2/3. Going into our second set of brackets here, writing all this down. These two minuses, as you know, become plus. So this will be plus a 12th. All right, so now we're kind of back to just a basic fraction question, needing a common denominator here. So I'm going to get a common denominator of 6 for the first one. And the second one, a common denominator of 24 will have to be done. Doing so, we're going to get 3 over 6 plus 6 over 6 minus 4 over 6 is going to get me 5 over 6 here minus 3 over 24 minus 12 over 24 plus 2 over 24. Don't forget your minus sign from before, but this is going to end up coming out to be negative 7 over 24. Continuing this question here, change the two minuses to a plus. And once again, we're going to have to get a common denominator. I'm going to multiply the top and bottom of this fraction by 4, and that'll give me 20 plus 7 over 24. And our final answer here is 27 over 24, but we have to check to make sure this is in fact in lowest terms. And if you notice here, I can divide top and bottom by 3. Dividing the top and bottom by 3 here, I end up getting here 9 over 8. So therefore, all of that work there, looking at that question, reduces to become 9 over 8. All right, that concludes today's lesson on working with exponents.